Hello everyone, thank you for watching my video. I'm going to go ahead and demonstrate my final project for my Embedded Systems class. I created a GPS data logger using the Arduino Uno, as you can see here, the Adafruit SD shield for micro SD cards, and the SparkFun GPS receiver. Cute little device here. Interfacing these three devices together wasn't too terribly difficult. I utilized Mikhail Hart's tiny GPS library through Arduino and kind of just, adjusted the code to do what I needed it to. This library specifically is located on Arduino.cc, as well as a tutorial on basic data logging with an SD card shield. Aside from the GPS data logger, I used code blocks to write a C file operations program that can perform basic math operations with the velocity and altitude data, as you can see here. This was obviously a little more complicated, but not too terribly bad. And then let's not forget the MATLAB program that was utilized to convert the CSV file, comma separated variable, that the SD card generates on the Arduino into the keyhole markup language, which is .kml, the Google's proprietary mapping utility file extension. With all of these scripts having been created, I went ahead and added a plug-and-play application to my Arduino, or my program, by creating a Windows batch file that runs all the C commands to open the various folders, which I will demo for you now. As you can see, one file was copied over from the SD card, which I already have plugged into my computer. Then we have a time delay, allowing MATLAB to open. It's a pretty big program. And then if you sit patiently, you'll see that it goes ahead and runs on its own. Another couple seconds here. I've got another delay waiting in the background there, as you can see. And then the Google Earth comes up, and it displays the trail that I took from my apartment in Westminster here to Gross Reservoir above Boulder. So you can see all the switchbacks and everything here, and that's all lovely. You come here and you can see the C file operations program. Option 1 allows us to view the satellite count. So at any given time in the US, there are between 6 and 10 satellites that can be viewed with a receiver. 7 satellites is the average number of satellites that I was tracking when I was using my device. Velocity data, I was able to calculate the average velocity for my traverse, which was about 35 miles per hour, and maximum velocity, which was 96. And the altitude data, my average altitude throughout the trip was 1,835.96 meters, MSL, mean sea level. And the entire latitude and longitude data for all 2,083 data points for your viewing pleasure. As you can see, there's quite a lot. So that's my program. Hope you enjoyed it. I certainly did, and I learned a lot. And thank you very much for your time.